All right, so in this video, we're going to continue with the what is a function section, and we're going to evaluate specifically piecewise defined functions, okay? So you can do the warm-up in your own time. So let's look down here at some piecewise defined functions, okay? So first off, let's define what that is. It's a function that is defined by different formulas on different parts of the domain, okay? So you can see this piecewise function it has two parts. It's f of x equals x squared if x is negative, okay? And it's f of x equals x plus 1 if x is 0 or positive, okay? So when we're evaluating the function, we need to make sure the value we're using for x, check which domain that falls into and use that specific piece, okay? So if we're evaluating f of negative 2, I need to determine which piece to use. So negative 2 obviously falls here where it says x is less than 0. So when I define the function, okay, or when I evaluate the function, I'm going to use this first piece. So f of negative 2 is going to be x squared, okay? And I'm going to replace x with negative 2. So I'm using the first piece. When I square the negative 2, I get f of negative 2 equals positive 4, okay? So that ordered pair, negative 2 comma 4, would be on the graph of this piecewise function. I'm not ever going to plug negative 2 into the second piece because it's not part of the domain established for that piece, okay? F of negative 1, same thing. X is negative, I got to use the first piece. So I'm going to say f of negative 1 equals negative 1 squared. When I square that, I get a positive 1. So the point negative 1 comma 1 will be on the graph of that function. All right. Now f of 0, I see 0 as both of these domains, but the only place 0 is included is right here. This says the domain for this piece is x is greater than or equal to 0. So when I'm evaluating for f of 0, I'm going to use the second piece. I'm going to use x plus 1. Okay. So f of 0 equals 0 plus 1, which is 1. So f of 0 equals 1, okay? So the point 0, 1 will be on the graph of this function. And f of 1, well, 1 is positive. It obviously falls into this second piece with that domain. So f of 1 equals 1 plus 1, which is 2, okay? So again, all we're doing here is evaluating for the different values. Make sure you choose the correct piece, okay? And later on, we'll graph these piecewise functions by evaluating and making a table of values. All right, let's try the next one. Okay, similar kind of problem. We'll go through this pretty quickly. So f of negative 3, okay, well, that falls into the first piece. So there's no place to plug in negative 3 because f of negative 3, f of any value 2 or less is always going to have the constant value of 5. So f of negative 3 equals 5. When I evaluate f of 0, that's still the first piece, so f of 0 equals 5. Okay, so what we've got here is we've got a horizontal line at y equals 5 from negative infinity up until 2. Okay, so any value, including 2, when I plug in 2, that's a part of this domain, so f of 2 is going to equal 5. So no real algebra to do there. I'm not plugging in any values for x because there is no x to plug into. All right, f of 5, now that falls into the second piece, the domain here, x is greater than 2. So I'm going to plug in 5 here for x. So 2 times 5 is 10 minus 3, which is 7. So actually a little bit of work there. Okay, so that's evaluating some basic piecewise functions. Now, let's look at a more complicated problem here. So what we got here, in a certain country, the income tax T is assessed according to the following function of income, which is using the variable x, okay? So the tax is equal to 0 if your income is less than 12,500. We don't know what the currency is, so notice there's no symbol for currency. We're not talking about the US, so it's not in dollars, okay? Your tax is going to be 18% of your income if you earned between 12,500, including that amount, up to, but not including 40,000 of that currency, okay? And then the third piece of this function, your tax, if you earned $40,000 or more, not dollars, currency, would be 26% of that value minus 1,500, okay? So we want to evaluate here using different values in the local currency. So if you had an income of $79.50, Well, that's obviously going to fall in this first piece here. So if you earned that much, you're going to use the first piece. Your tax is going to be 0. Okay? All right. So that individual owes no tax. Okay? 12,500. Okay? Which piece does that fall into? Okay? Well, this says X less than that amount. This says including that amount. Okay? So if you earn 12,500 of the local currency, we're going to use the second piece here. So it's going to be 0.18 times your income, and that comes to a total of 2,250. All right, so that individual is going to owe 2,250 in tax. Again, whatever the currency may be. All right, find the tax if you had an income of 19,000. Okay, well, again, that's going to fall in the second piece. 19,000 is between these two values. So we're going to pay 18% of that. So 0.18 times 19,000 is 3,420. So that individual will owe that much in tax. All right. And the final example here, if you earned 48,700, all right, well, that's obviously going to fall in this third piece here. So we're going to do 0.26 times that income minus 1,500. Okay, so use the third piece. 0.26 times 48,700. Multiply those together and then subtract 1,500. So that's going to be 12,662 minus 1,500. So the tax for this individual will be 11,162. All right. So that's one way, one real world scenario where you use piecewise functions. And we need to be able to evaluate those in that instance.